All right, so welcome back. So today we're going to be starting a new unit. We still have a few more units to get through. So today we're going to be taking a look at piecewise functions. Now this is something totally new for all of us. We've kind of hinted at it a little bit in one of my previous lessons, but now we're actually going to really delve into what it means. So piecewise functions. Well, if you break up that word, piecewise means we're going to be talking about functions and breaking them into pieces. But before we can do that, we need to recall some notation. Now, if you remember, if you include numbers within an interval, remember we use those square brackets. That means including. And this is for interval notation. This is actually really important. Notations like this is going to carry through for you all into geometry, algebra 2, etc. You guys need to know the difference. So interval notation, if we're including a set of numbers, we use these square brackets. Or if we're dealing with inequalities, we have our less than or equal to or greater than or equal to. All right, so those are our inequalities. This would be considered set builder notation, where we're using inequalities. All right? So let's keep going through. Now, if I have a set of numbers that say I'm not including the endpoints, I don't want to include the endpoints, well, then we use the open parentheses. We use open parentheses, which again, hopefully we do remember me talking about this. All right, so there's my open parentheses, or, and again, that's also interval notation. Or we can talk about using less than or greater than, where this is now set builder notation. All right, so just make sure we note the difference between the two. So I'll circle them here. Here's our interval notation. Here's our set builder notation. All right, awesome. So first things first, we want to write an inequality for each of the following scenarios. So we're going to be using inequalities. So I'm looking at the following notation here. Inequalities. We're going to be using set builder notation. Okay. So the question says, to get free shipping, you must spend more than $50. All right. Well, in order for me to spend more than, you guys need to remember your inequality symbols. More than looks like this. And I'll use the variable x. So I want to spend more than $50. Now the next question says, for a soccer team, you must have at least 11 players. Again, we need to know our key words here for the vocabulary. At least means greater than or equal to. So we have x is greater than or equal to that 11 players. If you're failing a class, well, that means you have a grade that's below a 65. So that means your grade is below a 65. Would I include 65? No, because a 65 is passing. So how would I write grades below a 65? Very good. X is less than 65, meaning you could have a grade of a 64, a 63, 62, etc. Anything lower, but you would not include 65. Okay, and then to be passing a class. Well, to be passing a class, you have to have a grade of at least a 65. So you have to have at least a 65 to be passing. So to have a grade of at least a 65, well, we're looking at greater than or equal to again. For remember, at least here we said was that greater than or equal to. Okay, so I'm looking at least a 65, so I have x is greater than or equal to 65. Now I want you to think about this though. I want you to take a closer look at C and D. If I'm failing a class, that means my grade is below a 65. So I gave some example numbers here. I said I could have a 64, a 63, a 62, etc. Could I have a negative score? Could I have a negative 10% as a failing grade? That doesn't make any sense. So what we're going to talk about is actually how to look at a compound inequality. Because really, your grade could be between a 0 and a 65 if you're failing. You can't have a negative GPA, negative percentage or average for a class. And again, if you think about passing a class, sure, your grade is going to be bigger or equal to 65, but could I have a grade of 2,000%? No. Yes, you may be getting some extra credit. Maybe you're looking at a score of a 105, but 2,000, that's so out of the question. So we're going to take a look at some compound inequalities here. So let's take a look at the example I give here, a 65 to 100. And let's take a look at this given that there's no extra credit involved, no extra credit, and no bonus. Okay. Well, this compound inequality, remember what I taught you guys. You always have less than in between, or less than or equal to in between. You never have greater than. That is always out of the question. So this is no good. Okay, so let's just continue with what I was talking about here. So we know that greater than and greater than, that is never what an inequality is going to look like. It's always going to look like the two scenarios you have here. Okay? Or, you could have the signs interchange. Maybe that is has an equals to place on it, or maybe it's the reverse. Maybe the equals to piece is here. Okay, so those are just some other options. All right, so given this compound inequality, I'm going to talk about everything that's going on here. Okay, so I just rewrote what we have here. So I want to take a look at both of these inequalities. Do you see how I have written here 65 is less than or equal to x? Well, we always want that variable on the left-hand side. So I'm going to flip the order here. Now notice, this symbol, if you want to think about Pac-Man, is eating x. So I need to write that symbol is still going to eat x. Okay? So if I look, this is really the same exact thing. 65 being less than or equal to x is equivalent to x being greater than or equal to 65. This is an equivalent statement. They're the exact same thing. Always want that variable on the left. And we also have, because this is a compound inequality, we use and. Remember I talked about earlier in the year and or? This is an and statement. So I have and x is less than or equal to 100. So if I were to look at this graphically, I'm just trying to break this down for you guys. If I were to look at this on a number line, so here I have my 65, here I have 100. I'm going to take a look at the first piece here of what I have in red for x being greater than or equal to 65. Because it has an equals to symbol, that means I get a closed circle. Similarly with 100, because it has the equals to piece here, this also gets a closed circle. Now if I look, I want x to be greater than or equal to 65, and it also has to be less than or equal to 100. So if I'm greater than 65, but I can't be bigger than 100, I'm in between this interval. That's what my compound inequality would look like. So x is in between 65 and 100. Now, if I want to take a look at this in interval notation, again, this is in our inequality notation or set builder notation. In interval notation, because I'm including 65, because it's got that closed circle, and I'm including 100, remember we use those square brackets here because we're including. So I'm going to write this in interval notation as 65 to 100. Both get square brackets. Okay? Two different ways of looking at it. So let's keep going. Now let's look at the features on functions. So again, we're all just getting this set up so we can start to graph piecewise functions, but we got to make sure we have the vocabulary and notation. So if I look at the features of a function, we have a function is increasing when the graph is going up from left to right. So if the graph is going up from left to right, then we know that that's an increasing function. We know that the function is decreasing if it's going down from left to right. So let's take a look at this first example here. This is our quadratic equation or quadratic function. For each graph below, determine the intervals for when the function is increasing and decreasing. So I want to know for the first question, where is this function increasing? So I'm looking here. I want to be going up from left to right. Well, let's trace along the graph. So here is one piece of the graph. Here's one portion. And here is the other portion. Okay. So whether I'm looking at the blue or the green, which part of the function is increasing? As I go from left to right, is this blue piece increasing or decreasing? Think about a roller coaster ride. No, this would be decreasing. So I'm looking at green being my increasing function, right? I'm starting below and then I'm going higher and higher and higher. So it's getting higher as I go. So I want to take a look. Which interval is this function increasing? Well, I'm going to take a look at what's that x value. That x value is when x equals 2. So I'm looking at all values when x is greater than 2. All of these values, guys, as I go from left to right, all these points, this is increasing. So when x is greater than 2. When I'm talking about increasing and decreasing functions, guys, I think hopefully you remember this. You immediately eliminate the equals 2 pieces. Immediately, if I'm talking about increasing and decreasing, you get rid of the equals 2 pieces. That makes no sense. You can't decrease or increase on a point. Nothing's happening at that point. It's staying still. Okay? All right, let's take a look at another example. Which one do you want to take a look at? We've got 2, 3, and 4. Sure, let's take a look at 2. Okay, so for question number 2, again, I already just reiterated this. When you're talking about a function increasing or decreasing, you immediately eliminate the equals 2 pieces. That makes no sense. So let's say, I'm going to break up my graph here. So I have this portion where there's a change in direction, and then I also have this portion where there's a change in direction. Okay? Let me just try to clean that up a little bit. Okay. So am I looking at this thing decreasing where it's green or where it's red? Good, where it's green. So if I were to follow this upwards, I'm looking at here, x is equal to -2. But now if this is the interval here, where x is decreasing, all of those values is where x is less than 2. So I'm looking at, -2. X is less than -2. So I'm looking at answer choice 3. Okay, and questions 3 and 4 you can do as your extra practice if you'd like. So maybe pause the video here and see if you can figure out the answers for 3 and 4, and then I'll post the solutions. All right, and there are your solutions for questions 3 and 4 if you decided to go ahead and try those. Okay, so let's keep going. Again, remember, if you look, I immediately eliminated any of the answer choices that had that equals 2 piece underneath. So if I saw this or this, I immediately was like, get rid of it. Gone. Okay, so let's keep going. We have the following. We have a 0 or root, so remembering that vocabulary. Does anyone remember what we also called a 0 or a root? What was another vocabulary term for zeros and roots? Very good. The x-intercept. Awesome. So you guys remember more than you think. Okay, so we have the 0 or the root of the function is where it intersects the x-axis, which is known as the y value being 0. Okay, remember, a maximum value is the highest y value that the graph is going to reach. And then a minimum value will be the lowest y value that the graph will reach. So let's take a look at some examples here. Again, this is all important vocabulary for us to know. That way we're all set for when we graph piecewise functions. Okay, so let's take a look at example question 5 here. So it says for each graph below, determine the zeros or roots of the function and state if it has a max or a min. And then we're going to state the max and minimum. And we're going to state the value. When I ask for the value of a max or a minimum function, that means I just want the y value. That's really important. If I ask for the value of a max or a min, it's just the y value. Okay, so keep that in mind. All right, so let's take a look. So for question number 5, we know that this is quadratic. So I'm just going to write this is a quadratic function because it has a parabolic shape. And the zeros or the roots for this function, it intersects when x is equal to 2 and when x is equal to negative 4. So those are my two roots. Those are my two zeros, when x equals 2 and when x equals negative 4. Okay, does this graph have a maximum or a minimum? So think about that roller coaster ride. Does this have a max or a min? Very good. So this would be a maximum, right? If I were to take a look at that coordinate point, we're looking at the point negative 1, 9. That's a maximum, right? Think about that roller coaster ride. You're going up in height, you reach that max height, and then you go down. Think about like King Ka. Okay, so this would have a maximum, and the maximum, and it wants the value, really important here, so you're not giving me negative 1, 0, negative 1, 9. That would be wrong. The maximum value here would just be 9. Okay? All right, let's take a look at another example here. Okay, so let's take a look at question number 8. So again, let's state the zeros of the function. And anyone know what kind of function this is? What kind of family of functions would this be? Linear, quadratic, exponential? What are we looking at here? What kind of function? Good, it's an absolute value because of the V shape. Okay, so what are the zeros? Well, it's intersecting the graph here and here. So that's the point negative, let's see, what is that? Negative 4, 0. And then this is the point 0, 0. So my roots or zeros are when x equals 0 and x equals negative 4. Okay, now again, think about the max or min. Does this have the lowest point on a graph or the highest point on a graph? So let's see, what's that point here? Is that the lowest point on the graph or the highest? That's the lowest point, so we're looking at a minimum here. And that minimum point ends up being negative 2, negative 2. Yep, negative 1, 2, negative 1, 2. Good. Okay, so I'm looking at the point negative 2, negative 2. So when I write the minimum value, I am not writing negative 2, negative 2. I want the minimum value. So if I want the minimum value, we're just going to write the y value. So we're just going to write negative 2. Why don't you try and see if you can do questions 6 and 7 on your own? So give that a try. Pause the video here and give 6 and 7 a try. Okay, so this is what you should be looking at for question 6. These are the two zeros. We're looking at an absolute value function where the zeros are negative 3 and 3. The function has a maximum at that point I labeled here for us, the 0, 3. And I want the maximum y value, right? If I say value, I'm looking at just y, so that value is just 3. Okay, let's take a look at question 7. Okay, and here is our solutions for question 7. We have our two roots are at negative 1 and 5 for when x equals those values. We're looking at a minimum, right? If I were on a roller coaster ride, this would be the lowest point on my graph. And then that minimum y value. So again, we just want the y value. If it says find the value of the minimum or max, is just at negative 8. Okay, let's just move on. We're almost done. So now we're going to talk about when functions are positive and negative. So a function is positive when the graph is above the x-axis. So we're going to write this as above the x-axis, and the y values are positive. Okay? We have a function as negative when the graph is below the x-axis, and the y values are negative. So let's just take a look at a few examples. So for the first graph, I want to know over what interval is this function negative? Well, for the graph to be negative, I'm looking at all of the values that are below the x-axis. So all these values here are what I'm looking at because this is below the x-axis. So over what interval are these values negative? Well, let's see. We're always looking with respect to the x-axis. So this point right here, let me label that. So this point right here, we have x is equal to -1. And then my x value here is equal to 5. So I'm looking at all of my x values being between -1 and 5. Now I want you guys to think about this. Am I including when x is -1 and when x equals 5? Why not? If I'm at the point here when x is -1, what does y equal? We know that that's a root. So if this is a root, we know that the y values are all 0. Is 0 a negative number? No. So you're looking at everything that's below the x-axis. Not on the x-axis, but below. So we're not including -1 and 5. Anything with an equals to is out. Those answer choices are out. Okay, so now all I have left are answer choices 1, 3, and 4. Now we know it can't be all real numbers because we've just established we're between -1 to 5. And we're not including -1 and we're not including 5. How do I write that compound inequality? Think way back to earlier in this lesson. I'm between -1 and I'm between -1 to 5, but I'm not including -1 and I'm not including 5. Good, we have those less than symbols in the middle. Awesome, in between. So there we go, answer choice 1. Okay, why don't we take a look at question number 11. So let's take a look at question 11. Over which interval is this function positive? So now if it's positive, I'm looking at everything that's going to be above the x-axis, okay? Everything above. All right, well, let's take a look at what these roots are here. We have this root is at x equals -4, and I have this root is at x equals 2. And where this function is positive is above the x-axis from here all the way over to here. Okay, so I'm looking at all my x values being between -4. So let's draw that on here. We're between -4 all the way to 2. So I'm including all my values between -4 to 2. Now you're not including the value at -4 and you're not including the value at 2. Remember, anything with the equals to is out because if I'm equal to 4, that y value is 0. And 0 is not a positive number. We're looking for the positive numbers. Okay? So I'm looking at x being between -4 and 2, but I am not including those values. So I'm looking at answer choice 2. If you guys want to give questions 10 and 12 a try on your own, I would pause the video here and see if you get the same solutions as me. So pause the video here and give 10 and 12 a try. Okay, hopefully you got the same answer as me for question 10. And let's scroll down to question 12. Okay, and again, the same thing here. Hopefully you got the same answer as me for question 12. Again, you should have immediately ruled out answer choice 3 because we don't want those equal to signs. You're over an interval. It can't possibly be all real numbers because all real numbers is talking about every single number possible. So that's out. And it can't be answer choice 2. So we're looking at 4. All right, let's finish it up. This is our last set of questions. We just got to recall what domain and range are. So if we remember, domain talks about the x values, and range talks about our y values. So another way to look at it is the domain are the x values. It's the leftmost and rightmost x values on the graph. And then for range, which again we said were the y values, those are the lowest and highest y values on the graph. So let's take a look at example 13 here. So let's identify for the range. The range we said are the y values. Those are the y values. Those are the lowest and highest points on the graph. So here's my lowest y value. Here's my highest y value. My lowest y value is at -5. My highest y value is at 4. So my range, if I'm going to write this in set builder notation, I'm including -5, and I'm going all the way to 4. I'm going from -5 to +4, and I'm including those values. If I want to write that in interval notation, because I'm including both of those points, we use the square brackets, and we're just going to write -5, 4. Okay, domain, we said, is talking about the x values. So remember what I said, the leftmost and rightmost x values on the graph. So the leftmost, well, let's see here, goes to -3. So I'm including that value at -3, right? I'm at -3 when x equals -3. And I'm going all the way to when x equals 2. But notice I have an open circle there at x equaling 2. So I'm going from -3, where I'm including -3, and I'm going all the way over to 2, but I'm not including 2 because of that open circle. Okay, and the way we write that in interval notation, because I'm including -3, it gets the square bracket, and 2 gets the open parentheses because it's not being included. All right, and let's just take a look at one more example, and you can try the rest of these for practice on your own. Okay, so let's take a look at question 14, and you can do 15 and 16 for practice if you'd like. So for question 14 here, we have, again, the domain is our x values, and we're looking at the leftmost x values, to the rightmost x values. So we're looking at when x is at -3 to then when x is at 7. Okay, so I'm including those points here. Those points are being included. So I'm going from -3, including those values, to 7. And the way we write that on interval notation is from -3 to 7 with the hard brackets. And then the range, remember we look at the lowest and the highest y values on the graph. So here is my lowest y value on the graph, that's at 3. And here's my highest y value on the graph, that's at 8. So I'm looking at including from 3 less than or equal to y less than or equal to 8. And again, we use those hard brackets because we're including those endpoints. Okay? Like I said, I mean, this is everything you guys really need for your Delta math homework to get started on that. But if you want to stick around just for a few more moments, we'll do questions 15 and 16 if you'd like. All right, so maybe pause the video here and see if you get the same solutions as me. Okay, and there you guys have it. This is everything that you need to know for our first lesson into our Piecewise unit. So making sure we're comfortable with this notation and the definitions, the vocabulary, etc. All right, I'll see you guys soon. Bye for now.